So we've been looking at the function of xylem, of this vascular bundle. Now what we're going to do is we're going to look at the difference in structure between phloem and xylem. And it's that age-old question, structure and function. We've looked at the function of xylem. We've also had a look in autotrophs, microscopic structures, as in transport systems within autotrophs. We spoke about, the PowerPoint spoke about this idea that phloem has a bit more going on with it. Xylem, in terms of its structure here, these big tubes here, right? These two big tubes here are the xylem, and this one here too. They're really just straws, lignified walls, dead cells. There's nothing, each of the ends is cut off, open, so it makes a long continuous tube, allowing the water and nutrients to go from the roots to the bottom of the plant against gravity all the way to the leaves, which I think is pretty cool, acting like kind of like a straw. Whereas phloem here, and we're starting to look at structure. So just for some context, this is the same root slide that we looked at in the roots, this is the same stem slide that we looked in the roots and stems investigation. Now look, if you look at the structure of our phloem cells, you'll see that each of these phloem have got a companion cell. They've got like a little buddy next to them. How cute is that? And what that companion cell is doing is helping to do a bit of horizontal movement of those products of photosynthesis. You also have sclerenchyma, which is maybe this cell here and this one, sort of the more cuboidal type ones, and this one here. This one just here, sorry. They're like giving structural support for the plant, the sclerenchyma. The parenchyma is like all the packing cells, so all of these densely packed cells around here. You can't see it too much in the, I think this used to be parenchyma. You can't see it too much in this and a bit over here. Parenchyma are the packing cells between other cell types. It helps the transfer of elements between the sieve cells and the companion cells. Now, for us to look at the sieve cells, or the tubes, the actual like porous ends that are allowing it to go from compartment to compartment and to different parts of the plant, and bidirectionally, as in it's not going just one direction like in xylem. We need to look at it in longitudinal section. So at the moment we're looking at something in transverse or cross section. Now we need to look at these vascular tubes as if the tube's been cut this way. I don't have anything to... If this is the tube, it's like we're going to cut it this way now. At the moment, it's cut horizontally. Now we need to cut longitudinally or vertically to see some of the differences in the structures between these cells. Okay, so now we've gotten to this image that you just saw me going from low power all the way to our highest magnification at 400 times magnification. And if you're looking on in your textbook, investigation 6.2 is the one that we're doing here with our aim to observe the microscopic structure, very important, structure, not function, of xylem and phloem. And these spirally type of ribbed sort of sections that you can see here, these spiral structures are part of our xylem. So our dead, you can almost see it's kind of like a continuous tube there. And if you come into this section here, you can start to see that we're starting to see some cells here that have got some darkened sieve plates. Okay, the sieve plates are the things that are the junctions between two phloem cells. And next to each one of them is a companion cell. Okay? So I believe that this is what we're looking at for type of a sieve plate, this area here, and these are some of our companion cells and our sclerenchyma, as in those supportive cells. So these here are our sieve plates here. And if you were to get sort of like a face on view, like you were looking up onto it like this, you would see that it had lots of pores in it, right? Now, what I want you to do in part of this prac, so if you go to number 10 on the prac, this is on page 177 of Investigation 6.2 in your textbook, it's wanting you to research some images of digital models of xylem and phloem. And microcomputed tomography, CT, is one method of producing those type of images. Basically, it's a comparison to say what we've seen here and some other higher power imaging sources. Like, it's also interesting to note, like, what is the difference between that cross section that we looked at, or the transverse section, and this longitudinal section? Which of that do you need? Both of them to get the same amount of? Do they both give the same amount of information? Do you need both to learn about the structure of xylem and function, or can you just do it without it? And then what else do I want to say? Oh yeah, how do these digital images increase your understanding? Really is the focus. Especially, I think the biggest and most important thing about these pracs is just stimulating again this idea, what is the difference between structure and function? How does the structure of xylem, how does the structure of phloem allow it to function the way it needs to for the plant to function optimally? Remember that in a multicellular organism, each one of these different types, differentiated, specialized cells, is relying on the other for this organism to function. They can't survive by themselves. They need to all be working as a team. And I think there's maybe an analogy there for the church in that regard, you know. So you can think about it a little bit in that way. So have a go at doing Investigation 6.2 on pages 176 and 177 of your textbook. Remember, this is structure, not function, but we always have to start thinking about what is that link between structure and function. Thanks.